Hello and welcome back to another video. Today we will be looking at quadratic inequalities. Um, this is usually very simple. All you have to know what it is that if you have a curve, well, not like that, like this is the y equals to 0 line. And if you want to know the values where the curve is less than 0, you just have to find this x1 and this x2, and then we will provide it in a range stating something like, okay, I should have used something else, but something like that. Okay, so all of these can be different values. This is meant to be x, this is meant to be an actual value, this is also meant to be an actual value. Okay, so it can also be for the opposite, but we're going to get into that. So to get started, we have an example: 2x 2 bracket x minus 5 not equals less than 9. So this is the less than sign. You can also have the greater than sign. You can also have less than or equal to, greater than or equal to, or equal to, everything like that. But here in this question we have less than. Okay, so you have to just solve for x. So that's pretty simple. You can first distribute. That'll be 2x minus 10 less than 9. By the way, this acts exactly like an equal sign, so don't bother worrying yourself about how this works. It's exactly like it, like the equal sign. So 2x, and then we can take the minus 10 to the other side, giving us 9 plus 10. This gives us 19, okay? And then 2x less than, and then x will be less than 19 over 2, 9.5. Yeah, that's it. That's our value, or our domain, or values of x that are. So if we have any value that is less than 9.5 and we put it into this equation, we should get a value that is less than 9. That is the idea. Okay, so now that you've seen what this is, let's go into the main topic of this video, which is quadratic inequalities, which is what we're really here for. Okay, so let's start off with this one. So we have x squared minus 3x minus 4, which is greater than 0. So we can quickly graph this. Since this is positive, we should know that this is going to be a minimum curve, and we can quickly find out the roots. If you don't remember what the roots are basically these values. So if you have a curve like this, anywhere where in your coordinates y is 0, you can have a here. This could be a0, this could be b0. Anywhere your y is equals to 0, that will be your root. Okay, so here you can quickly use our calculator that we've gone over before. So x minus 4, then x plus 1 less than 0. You can just say x is equals to 4 and x is equals to minus 1 just for now, but you're going to have to change it later. So the next step is you have to first of all figure out if it's a minimum or maximum curve. Well, we figured out it's a minimum because this place is positive. Okay, so let's quickly draw a curve like that. Something like this. I want this to be minus 1, this to be 4. Okay, and it says that this curve is greater than 0. Okay, so all the values, so where is it greater than 0? It's greater than 0, all these values and these values. Keep in mind that this is 0, y equals to 0 line, and these are the values that are greater than 0, and these values are less than 0, all these values here. Okay, so you can just say, well, if x was less than minus 1, we'd be satisfying this condition, or if x was greater than 4, and that's your answer. Okay, you can also use your calculator if you have the Casio ClassWiz. That will also help you do this a bit quicker. I'm going to take this this example, x minus 3 squared less than or equals to 0. So this is already in root form because it's the same thing as saying x minus 3, x minus 3 less than or equal to 0, okay? And if you were to expand it all the way over here, you get x squared minus 6x plus 9 less than 0. So we know this is positive. We can quickly draw our, and we know that it's going to be touching on one point. Let me just, let's make this, actually it's meant to be 3, yeah. So 3. So x is, meant to equal to 3. And now you have to figure out how it is. So it's not a great one. Okay, well, good enough. So this is 9, in case you weren't aware. I haven't labeled my axes, but these are x and y. They're always x and y. Okay, so here, what are they asking us? They're asking us, this curve is less than 0. So make sure we keep an eye on the sign. So less than 0. Less than 0, well, the curve is pretty much never less than 0. Or less than or equal to 0. I mean, it is equal to 0, but it's not ever less than 0. So because there's nothing here, right? Let's try one more. Okay, let's try one with modulus. If you don't remember what modulus is, it's basically if you have a negative value like this, gives you a positive value. Okay, so let's do that. So x squared plus 2x minus 2 modulus less than 13. So you have to solve two equations here. So let me quickly do that. That'll be x squared plus 2x minus 2 less than 13, the normal one. And then the other one where we're going to assume that, this is negative. Okay, so we can have two of these. That's 2x minus 2, but instead of multiplying a negative in this, we can just multiply the negative here, and it still does the same thing. Okay, I should also sketch it. One root is over here, minus 1 plus root 3. The other one has to be the negatives. Okay, so minus 1 minus root 3. So these are the roots. Okay, and it goes like this. Doesn't have to be accurate, just have to be a rough sketch. And this can be your y equals to 13. Okay, we're going to have to look at that. And since the equation or the question is asking for 13, you look at 13, not minus 13. Okay, all right, so here, okay, let's quickly solve this. So x squared plus 2x minus 2 minus 13 less than 0. So this gives us, I'm gonna quickly solve this, skip a few steps. Okay, this gives us x is equals to 3 and x is equals to minus 5. Okay, let me just write this in the other form. 0. Okay, so x is equals to 3 and x is equals to minus 5. Okay, so I'm guessing this is where x is equals to 3, and I guess this is where it's equals to minus 5, I'm assuming. And then we can do the same thing for the other side. Use right here, x squared plus 2x minus 2 plus 13. Keep in mind, if you get imaginary values with the letter I, you can just ignore that. Okay, so if you try to solve this one, you get imaginary values, okay, with the letter I. So when you have that, you can just ignore all of this. So we're just gonna ignore all of this. Okay, so let's come here. So what are we looking for? They're saying this equation, x squared plus 2x minus 2 in modulus, is less than 13. So if this is 13, we're just looking for all these values down here. Let me quickly, yep, all these values, everything down here. So that's pretty simple. We just have to write the range, and x can be less than, oh, hold on, x can be greater than minus 5. That's what I meant. And x can be less than 3. With this range, all these values are included, all of them over here. So that's how you do it. And that's pretty much it. Thanks for watching.